Hello everyone, good morning. Welcome to the session of coordinate geometry. Today let me explain some graphs of geometry. Okay, very useful. Graphs are very useful in the mathematics, particularly in geometry. Let's see. So let me discuss the graphs of some basic algebraic functions. Graphs of some basic algebraic functions. Okay. So this is the topic today. Okay, graphs of some basic algebraic functions. Among those, let me explain first graph as graph of f of x equals to x. Graph of f of x equals to x, which is called an identity function. It is we have to say this one as identity function. Okay, this is. So how it is? Let y equals to f of x. Suppose I am taking. Let y is equals to f of x. Then clearly y is equals to x. Let y equals to f of x, then y is equal to x. So I have to draw this line y equal to x in the graph. So first you have to identify the points on this line. Okay, like this. Suppose x equals to 1, abscissa is 1, then y is 1, x2, y2, x3, y3, x value minus 1, y value minus 1, x value minus 1, then y value minus 1, like this, minus 2, minus 2. So these are all the points lie along this line, y equal to x. Y equal to x means x equals to y in the order pair. The points lie on this line having same abscissa, same ordinate. 1, 1, 2, 2, 3, 3. Such points lie on this one, y equal to x. Suppose you have to go to the coordinate system. This one. Okay. This is x axis, you know. This is y axis, you know. It is origin. So if x0, y0, origin, x0, y0, you know. So origin having same abscissa, same ordinate. Okay. So origin is also lie on this line. Next 1, 1, 1, 1. So this is 1, 1, you know. This point covers 1 unit distance along the x axis. The same point covers 1 unit distance along the y axis. This is called 1, 1, you know. So in the same way, this is 2 units along this line. This is 2 units. Then you have to the point there. This is 2, 2. Okay, this is 2 like this. So 1, 1, 2, 2, 3, 3. Suppose you have to identify all such points like this. Okay, minus 1, minus 1. It is minus 1. Suppose it is minus 1. Suppose it is minus 1, minus 2, like this. So you have to connect all these points. This is the line y is equals to x. This is the line y is equals to x. This is the graph of f of x equals to x. This is the graph. Y equal to x. This is the line. This one has all the points with abscissa is equal to ordinate. This one has all the points with abscissa is equal to ordinate. 1, 1, 1 by 2, 1 by 2, 0, 0, 2, 2, 3, 3, 4, 4, minus 1, minus 1, minus 2.5, comma, minus 2.5 like this. So such points, if abscissa equal to ordinate, such all points lie along the line y equal to x. This is the curve. This is the y equal to x. This is a straight line. Y equal to x is a straight line. This is passing through origin. We have to add one more point here for this concept. Y equal to x is a straight line. Y equal to x is a straight line. This is a straight line. This is a straight line. This is a straight line which is passing through origin. This is a straight line passing through origin. This is straight line passing through origin and make an angle. How much angle here? What is the slope of this line? This is the line passing through origin. Come on, one. What is the slope? y2 minus y1 by x2 minus x1. 1 minus 0 by 1 minus 0, 1. The slope of this line is 1. Suppose I have to take the point 2, 2 here. 2, 2, 0, 0. What is the slope? 2 minus 0, y2 minus y1 by 2 minus 0, 1. Slope is 1. You have to take any 2 points on this line. Then apply the formula y2 minus y1 by x2 minus x1. Then you will get the slope of that line. It is clear. The slope of this line is 1. Suppose the inclination of this line is theta. The inclination of this line is theta. Then slope of the line is tan theta. It is clear tan theta is equals to 1. Okay. This is the slope of this line. Suppose it has inclination theta. It has inclination theta. Then the slope of this line is tan theta. We have to take any 2 points on this line and apply the formula y2 minus y1 by x2 minus x1. You will get the value 1, slope value 1. So it is clear tan theta is equals to 1. Tan theta is equal to 1 means theta is equal to 45. So this is 45. So this is a straight line. Y equal to x is a straight line passing through origin and making making an angle. This is y equals to x line and making angle 45 degrees with x axis. Just you have to observe this one. Okay. This is a straight line y equals to x. Okay. This is a straight line y equals to x. We have to extend this line more. This is a straight line y equals to x. This is passing through origin and making an angle 45 degrees with x axis. This is something about y equal to x line, f of x equal to x graph, which is called identity function. Which is called an identity function. Okay, that's one. Okay, let me explain one more graph here. This is first graph. Okay, see. Second one. The graph of f of x equals to minus x. In the previous graph tells about f of x equals to x. This one tells about f of x equals to minus x. So let y equal to f of x. Suppose automatically y is equal to minus x. If I am taking y equal to f of x, then that should be written as y is equals to minus x. So this is a straight line. It is also form x plus y equal to 0. Suppose you have to take minus x to left side, then it is x plus y equal to 0. It is a straight line. So what are the points formed on this line? So to get the point formation on that line, put x equals to 1, then y value is minus 1. Put x equals to 2, then y value is minus 2. Put x equal to 3, then the value y value is minus 3. If abscissa is positive, then ordinate is negative. So the point on this line is of the form like this, 3 comma minus 3 and so on. Okay, suppose x equals to minus 1, x equal to minus 1, y value 1, abscissa negative, then ordinate is positive, x equals to minus 2, y value 2, like this, x 0, y 0. So every point on this line is of the form 1 minus 1, 2 minus 2, 3 minus 3, minus 1, 1, minus 2, 2. What is observation there? We have to notice that abscissa and ordinate is equal in magnitude, but they are coming with opposite sign. Okay. So here the abscissa and ordinate having same magnitude, but they are having opposite signs. If abscissa is positive, then the ordinate is negative. If the abscissa is negative, then the ordinate is positive there. Suppose you have to locate all these points, all such points in the graph, and you have to connect all those points. You will get the graph of y equal to minus x there. Okay, so the first point is 1 minus 1. The first point is 1 minus 1. 1 minus 1, have this one. 1 minus 1. It covers a distance of 1 unit along the x-axis. The same point covers a distance of 1 unit along the negative y-axis. 1 comma minus 1, you know. So it is 1 minus 1. Okay, in the way 1 minus 1, 1 minus 2 minus 2, it is 2, it is minus 2 like this. So you have to minus 1, 1, minus 1 it is, 1 it is, so there. So you have to identify all the points there and you have to connect all those, then you will get a straight line like this. This is y is equals to minus x line. Okay, this is okay, this is. So this one has 0 0, this one has 1 minus 1, this one has 2 minus 2, this one has minus 1 1, this one has okay, this one has minus 2 comma 2 like this. So it is a line y is equals to minus x, it is the line y equal to x. In this line y equal to x, all the order pairs, all the points lie along this line have abscissa with ordinate. Abscissa is equals to ordinate. In this line, so many points are there. All the points on that line, having same abscissa and same ordinate in magnitude, but they are having opposite signs. If abscissa is positive there, then the ordinate is negative. If the abscissa is negative, then the ordinate is positive. Okay, this is the line y is equals to minus x. This is the line y is equal to minus x. This is the line y is equals to x. Okay, these are the graphs about y equal to x and y equal to minus x line. So this is the line passing through origin having 45 degrees, making inclination 45, making an angle 45 with x axis there. In the same way, this is the line, this is also passing through origin. This one makes an angle 135 degrees with x axis. Just have to observe that one. It is a line passing through origin y equal to x, passing through origin and making an angle 45 degrees with x axis. But what about this line? This is also a line passing through origin. That one subtends an angle 135 degrees with x axis here. Okay. Okay. Let me explain one more graph, which is y equals to x square. F of x equal to x square graph we have to discuss now, which is also called square function. Okay. See, the graph of f of x equals to x square. Graph of f of x equals to x square. It is called square function, also called square function. This is there. So f of x equals to x square. So let y equal to f of x first we have to take. Let y is equals to f of x. This implies y is equals to x square. So this is a equation here. So first we have to find the point form on this equation. Okay, what is the point form on this one? So to get the point form on this equation, first I am taking x equals to 0. X 0, automatically y 0. So 0 0 lie along that equation. Suppose x equals to 1, then y equal to 1 square. X equals to 2, y equal to 4. X equals to 3, y equal to 9. Okay, observe all these. X equals to minus 1 whole square, y value 1. X equals to minus 2, y value 4. X equal to minus 3, y value 9. I have understood. So these are all the points lie along this equation, this curve. This is a curve. Suppose you have to identify all those points in the graph. You have to take x and y axis coordinate system. Listen to me. This is x axis, this is y axis, you know. So 0, 0 lie along this line, along that curve, 0, 0, 1, 1. So 1, 1 means that point covers 1 unit distance along the x-axis, the same point covers 1 unit distance along the y-axis. It should be like this, 1, 1. Next, 1, 1 means 1, 1 after 2, 4. So this is 2. This is 4. 1, 2, 3, 4 maybe. This is 4. Okay, just rough diagram it is. 3, 9. This is 3. 9 should be like this. Like this. I have understood. So rises fastly. Y coordinate rises fastly. Okay, compared to abscissa. Abscissa 1, 2, 3 like this. That rising like this. Ordinate 1, 4, 9. Compared to abscissa, ordinate rises fastly. So curve like this one. Curve goes like this. Okay. Okay. So what about this side of y-axis? Left side of y-axis. Suppose x equals to minus 1, y value 1. X equals to minus 1, y value 1. X equals to minus 2, y value 4. Same. Same. So we have to connect all these. We have to connect all these. We will get the shape of this one. Okay. Just you have to say there. Okay, like this. Okay, this is the point 1, 1. This is the point 2, 4, maybe. This is the point minus 1, comma 1. This is the point minus 2, comma 4, like this. So we have to connect all those points of these. You will get the shape of this one. This is a parabola. So this is the curve y equal to x square. This one represents a parabolic curve, parabolic shape. So y equal to x square graph represents a parabola. Okay. So this is a parabola. It is a parabola passing through origin. Parabola. That one is passing through origin and passing through origin. That curve is symmetric about y-axis there. Just you have to observe that one. It is a curve. This one is symmetric about y-axis. It is a mirror. So this part is mirror image of mirror image. This is a mirror. The mirror image of this one. You have to put mirror there. Then the image of this one should be like this. You have to put mirror here with rest on the y-axis. Y-axis is a mirror here. Then the image of this one in this mirror. This should be this one. That means this curve is symmetric about y-axis. We have to say that curve is symmetric about y-axis. It is a shape of y equal to x square on right side of y-axis. Suppose it is a mirror. The image of this one, this part is nothing but this one. The image of this shape, this part, which is left side of the y-axis, it is nothing but the image of left side of y-axis of this curve with respect to y-axis. Y-axis is a mirror. That mirror image of this part is this one. So we have to say y equal to x square is a curve, that one is a parabola, that one is passing through origin and it is symmetric about y-axis. It is symmetric about y-axis. Okay, you have to notice that one. So y equal to x square is a parabola which is passing through origin and that one is symmetric about y-axis. Okay, this is called also square function. Also this one is called as square function. Okay, let me explain. Okay, so let me explain one more graph which is f of x equal to x cube. This one is called cube function. This is called cube function. Okay, what about previous graph? That is f of x equal to x square, that is square function. What about first one? F of x equal to x, that is identity function. So f of x equal to x, y equal to x is identity function. F of x equal to x square, nothing but y equal to x square is a parabola. Square function, Now y equal to x cube it is, f of x equal to x cube, that is called cube function. So let y equal to f of x here, let y equals to f of x here, automatically this one is y. So y is equals to x cube. So we have to draw on this one, y equal to x cube curve we have to draw now. So to get the graph of y equal to x cube, first we have to observe the point form on this curve. So to get the point form on this curve, we have to take arbitrary some, we have to give some values for x, then we will get y values also there. Suppose x equals to 0, x is 0, then y is 0, x is 1, y is 1, x is 2, y is 8, y rising so fastly, x came from 1 to 2, but y came from 1 to 8, y rises fastly there in this curve. I have to think like that, x value 3, y value 27, rising more. Okay, left side of y-axis we have to think. If x equals to minus 1 whole cube, minus 1, minus 2 whole cube, minus 8, minus 3, minus 27, I have understood. So these are all the points on this curve. Okay, now let me draw that curve now. This is coordinate system, it is x-axis, it is y-axis. So it is 0, 0. Okay, this is 1, 1, 1, 1. So 1, 1 maybe like this, 1, 1 it is. Then next point is 2, 8. Our next point is 327. So 2, 8. So y coordinate rising so fastly there. 2, 8. Maybe here. 1 it is, 8 it is. Suppose. Okay, this is 2, 8 maybe. 327, I have to imagine. So on the left side of y-axis, minus 1, minus 1. Minus 1, minus 1 maybe. Minus 1 it is. Minus 1. Both are negative. So it is in the third quadrant. Both are negative. Both are negative means the point located at third quadrant. So this is minus 1, minus 1. That means this point covers minus 1 unit distance along the negative x-axis, 1 unit distance along the negative x-axis, 1 unit distance along the negative y-axis. That is the meaning, you know. So this is minus 1 comma minus 1. Next minus 2, minus 8 is there. Minus 2, minus 8. So suppose it is minus 2, minus 8 becomes like this. Suppose you have to connect all these, then you will get the shape of like this. This is there. Okay, so 2, 8, this is minus 2, minus 8. This is minus 2, minus 8. So this is the curve y equal to x cube. This is the curve y is equals to x cube. Okay, so this is also the curve passes through origin. This is called cube function. That cube function is passing through origin, and this curve is symmetric about origin. This curve is symmetric about origin means this is passing through 1, 1, and also this is passing through minus 1, minus 1. Suppose you have to take the midpoint of these two, you will get this one. You have to take the midpoint of these two, you will get this one. That is, it is a mirror. It is a mirror. So the image of 1, 1 with respect to this mirror, origin is mirror. The image of 1, 1 with respect to this mirror is minus 1, minus 1. So every point on this part are mirror images of these points with respect to origin. Every point on this part, every point on this part is mirror image of the point in this part with respect to origin. Origin is a mirror. So this curve is symmetric about origin, we have to say. But y equal to x square, y equal to x square shape like this. Like this, y equal to x square. That one is symmetric about y-axis. Y-axis is mirror there. Y in the square function, not a cubic function. In the square function, y-axis is the mirror. Y-axis is the mirror. So that function is symmetric about y-axis in the square function. In this one, in this cube function, the curve is symmetric about origin. In the square function, the curve is symmetric about y-axis. In the cube function, the curve is symmetric about origin. with respect to origin, every point image of this path lie in this path with respect to the mirror of origin. Okay, so the curve is symmetric about origin. So it is clear the curve is passing through origin. The curve is passing through origin and passing through origin and symmetric about origin. The curve is passing through origin and symmetric about origin. But y equal to x square is passing through origin and symmetric about y axis. Square function is symmetric about y axis. Q function is symmetric about origin. You have to remind that one. You have to notice that one. Okay. Let me explain one more graph. So the next graph is graph of absolute value function. Graph of absolute value function. Okay, graph of absolute value function, which is also called modulus function. Which is also called modulus function. Graph of absolute value function, which is also called modulus function. Okay. So what is the modulus function definition? So modulus, this represents modulus of x. This represents modulus of x. This is a function represent modulus of x there. Okay. So graph of absolute value function, which is modulus function, mod of x represents modulus of x. This one represents modulus of x. Okay. Also called absolute value of x. Absolute value of x. So modulus of x is denoted with this symbol. Just you have to notice that one. It is also called absolute value of x. What is the definition of modulus of x? Modulus of x is equals to, the definition of modulus of x is equals to x, where x greater than or equals to 0. If x is equal to 0 or if x greater than 0, then mod x is x. If x less than 0, mod x is minus x. This is the definition of modulus, you know. So mod x equals to x. X is greater than or equals to 0. Mod x equal to minus x if x is less than 0. So what is the graph there? See here. Okay. This is x axis. This is y axis, you know. So this is origin. What this one says? Mod x equal to x. X means y equal to x. This is a function, mod x. Okay. Mod x equals to x. That means y equals to x. Y equals to x, where x greater than or equals to 0. Y equal to minus x, where x less than 0. That means x is 1, x greater than or equals to 0. X greater than or equals to 0. If x equal to 1, you have to take this case. X equal to 2, you have to take this case. X equal to 3. If x greater than or equals to 0, you have to take this case. If x equals to minus 1, we are taking this one. If x is less than 0, we are taking this case. If x greater than or equals to 0, we are taking this case. Just you have to remind that one. Suppose x equal to 0. X equal to 0 means here. This covers x equal to 0, then x 0. X 0, y 0. X is 0, then y 0. X1. X1 means 1. X value 1. 1 is greater than or equals to 0. Okay. So x equals to 1, that means 1 is greater than or equals to 0. X equals to 1 means that 1 is greater than or equals to 0. At that situation, x is 1, then y is 1. X is 2, y is 2. X is 3, y is 3. X is 4, y is 4. If x greater than or equals to 0, y equal to x. x1, y1, x2, y2, x3, y3, that like that. So it is nothing but y equal to x line. Already I explained about that one. This is the line. 1, 1, 2, 2, 3, 3, like this. This is the line y equals to x there. So if x positive, if x greater than 0, x1, y1, x2, y2, x3, y3. If x less than 0, if x less than 0, y value is minus x. If x less than 0, y value is minus x. Okay? If x is less than 0, if x equal to minus 1, x value minus 1, then y value is x value minus 1, then y value is minus or minus 1. Minus or minus 1 plus 1. So x equals to minus 1, then y value is 1. X equals to 2, x equals to minus 2, x equal to minus 2. X less than 0, y equal to minus x. X equal to minus 2 means that is less than 0. So y equal to minus x we have to take. X equals to minus 2, then y equal to minus or minus 2. Minus or minus 2 plus 2. I have understood, Gal. Okay, x equals to minus 3. X equals to minus 3, then y equal to 3. Okay, so in this way we have to draw on the graph of y equal to minus x, this one. Okay, so this is the graph. Okay, this is y equals to minus x. So if x greater than 0, then we have to take y equal to x line. If x less than 0, then we have to take y equal to minus x line. Already I explained about the line y equal to x and y equal to minus x at starting. Okay, so this is 1, 1, 2, 2, 3, 3. This is minus 1, 1. This is minus 2, 2. This is minus 3, 3, like this. So this is the curve mod x. This is the curve mod x. Okay, so this is the function which is passing through origin. It is also passing through origin, and this is also symmetric about y-axis. Okay, so modulus function, absolute value function, it is also passing through origin. It is also passing through origin and symmetric about y-axis. We have to remember this one. This is modulus of x function graph. Okay, let me explain some properties of modulus function now. Okay, what are the properties of modulus function? So properties of modulus function we have to discuss now. Properties of mod x. Okay, suppose mod x less than a. Mod x less than a. What is the meaning of this one? Mod x less than a, then the text lies between minus a to plus a. Take a positive. Okay, to avoid that confusion, I am taking a as positive, belongs to R. A belongs to R. A is real value and A is positive. Positive real value, suppose. A belongs to R plus. A belongs to R plus. I am taking like this. So A is positive, which is a real value. Suppose mod x less than A. Mod x less than A means the text lies between minus A and plus A. I have understood. See? Mod x less than A. That means the text lies between minus a to plus a. Okay, it is. So what is the meaning? Suppose this is a coordinate system. It is x-axis. Okay, so the text lies between minus a and plus a. This is the case. So if there mod x less than a, then we have to say the text lies between minus a to plus a. That x value lies between minus a to plus a. That is the meaning. If mod x less than or equals to a, then that x value lies between like this, minus a less than or equals to x less than or equals to a. That means x should be minus a or x should be a, or x is the value between any x is a value which is equals to any value between minus a and plus a there. So, mod x less than or equals to a, then that x lies between minus a and plus a like this. Suppose mod x greater than or equals to a, mod x greater than or equals to a, mod x less than or equals to a, that x lies between minus a and plus a, mod x greater than or equals to a, that x not lies between minus a and plus a, that x not lies between here in the coordinate system, x not like between these two mean x lies here or here. That means x naught lies between minus a and plus a, that means x less than minus a or x greater than a. Okay, so if mod x greater than or equals to a, this implies x less than or equals to minus a or x greater than or equals to plus a. This is the meaning. Okay, next third property is suppose I am taking mod of x plus y. X, you have to take any real value, y you have to take any real value. Mod of x plus y is less than or equals to mod x plus mod y always. You have to take any real value and check this is right or not. Okay, it is inequality. At the same situation, we have to say mod of x minus y is also less than or equals to mod x plus mod y. It is one more property. So, mod of x plus y less than or equals to mod x plus mod y, mod of x minus y is also less than or equals to mod x plus mod y. So, one more, mod of x plus y greater than or equals to mod of x plus y greater than or equals to modulus of mod x minus mod y whole mod. So, it is always mod of x plus y always greater than or equals to modulus of mod x minus mod y. In the same way, one more property, mod of x minus y is also greater than or equals to mod of mod x minus mod y. Okay, mod of mod x minus mod y like this. So, these are all the properties. These are all the properties which are belongs to absolute value function, modulus function. You have to check by taking any two real values instead of x and y. Okay, you have to verify all these. Suppose you have to take this one. I am taking x value is minus 3, y value is minus 4.5. Y value is 5.5 some. Just you have to check this one, mod of x minus y. What is mod of x minus y? Mod of x minus y is equals to mod of minus 3 minus of 4.5. Okay, mod of x minus y is equal to mod of minus 3 minus 4.5. Mod of minus 3 minus 4.5, mod of minus 7.5. Mod of minus 7.5, it is nothing but 7.5. Modulus of minus 7.5 is 7.5. Suppose I am taking x is equal to minus 3, y is equal to 4.5. Then this left side, mod of x minus y value is 7.5. What about right side? Just you have to check right side also. Mod x. Mod x is mod minus 3. Mod minus 3 is equal to 3. Mod y. Mod y is equals to 4.5. It is also 4.5. Mod x minus mod y, that is mod of mod x minus mod y, 3 minus 4.5. 3 minus 4.5 minus 1.5. What is minus 1.5 mod? 1.5. So, what is right side? 1.5. What is left side? 7.5. 7.5 is greater than or equals to 1.5. So, in this way, you have to check all the properties of modulus. Okay. So, mod x plus mod y. No. First property is mod of x plus y. First property is mod of x plus y. Mod of x plus y is always less than or equals to mod x plus mod y. Mod of x minus y is also less than or equals to mod x plus mod y. Mod of x plus y is greater than or equals to modulus of mod x minus mod y. In the same way, mod of x minus y is greater than or equals to modulus of mod x minus mod y. So, this is something about modulus function and modulus graph. Next, we have to define one more function which is called signum function. Okay, which is called signum function. The next one is graph of graph of signum function, graph of signum function. So this is one more graph. So this is graph of absolute value function, which is called modulus function. Now I am explaining the graph of signum function. The signum function, that means graph of, I am taking that function f of x as signum function. This is denotation. Okay. So we have to draw this graph. First we have to define what is signum function of x. What is the definition of signum function of x? Signum function of x is defined as, that is equals to mod x by x if x not equals to 0. Signum function is mod x by x, where x not equals to 0. 0, x equals to 0. So f of x equal to signum function. We have to draw this graph. First we have to define, we have to write the definition of this one. The definition of signum function of x is this one. If x not equals to 0, signum function of x is mod x by x. If x equal to 0, signum function of x is 0. This is the definition of signum function. Now we have to draw that one. We have to represent that in graph. Okay. So let y equals to f of x. Suppose I am taking, let y is equals to f of x. Okay. So let y equal to f of x means y equal to signum function of x. Okay. This implies y is equals to signum function of x. Y is equal to signum function of x. The definition of signum function of x is like this. X not equals to 0, mod x by x. X not equal to 0 means either x is positive or negative. If x is positive, mod x is x. If x is positive, mod x is x by x is 1. That means we have to rewrite this one as x is positive, x greater than 0. I am writing here. So this implies y is equal to signum function of x. That means that signum function of x is, if x positive, x greater than 0, this is x. X by x is 1. So 1, where x greater than 0. If x less than 0, x less than 0, mod x is minus x. Minus x by x is minus 1. So x less than 0, minus 1. X equal to 0, already there, 0. X equal to 0, 0. X positive, x by x. X negative, minus x by x, minus 1. This is there. This is the, we have to rewrite the signum function definition like this. What this one says, y equal to 1, x greater than 0. Y equal to 0 if x equal to 0. Y equal to minus 1 if x less than 0. So we have to draw the graph of this curve like this. See here. This is our coordinate system, x axis, y axis. So what this one says, if x is positive means x greater than 0. Then what is the value of phi? 1. Suppose 1 is there. So if x greater than 0, x value 1, y value 1, x value 2, y value 1, x value 3, y value 1. If x greater than 0, you have to take any x value which is greater than 0, then the y value is 1, constant. So this is there. Okay, x value 1, y value 1, x value 2, y value 1, x equal to 0, y 0. So it not covers here. So we have to hold there. So if x equal to 0, this line not covers here. So x greater than 0, this is the line, this is the curve. If x equal to 0, y equal to 0. If x less than 0, y value is minus 1. X less than 0 means if x is taking here, the value of x taking here, suppose x value minus 1, y value minus 1, x value minus 2, y value minus 1, x value minus 3, y value minus 1, this is there. Okay, this is y is equals to 1, this is y is equals to minus 1, this is 0. Okay, it not covers. So if x greater than 0, y is equal to 1, if x is equal to 0, y is equal to 0, if x less than 0, y is equal to minus 1. So this is this one, this line, origin, this one. That one represents the signum function of x. Okay, y is equal to signum function of x. Signum function of x definition is mod x by x. If x not equals to 0, if x equal to 0, that is 0. So we have to rewrite that function y equal to signum function of x is equal to x positive, that becomes 1, x negative, that becomes minus 1, x equal to 0, y 0 already there. So by using these credentials, we have to draw this graph. That one looks like this. Okay. So it is a curve, it is a graph about signum function of x. Okay. Thank you.